All right, so glad to see that Zoom worked because as a Google employee who only uses a competing product to Zoom, I was a little doubtful. But I could not have asked for a better introduction than Michael. I was originally slotted to speak in the afternoon, but Yuri gracefully swapped slots with me, but it has worked out well. So take everything Michael just said about the motivations for the cloud, and instead of AWS, just imagine he had said Google Cloud, and that's a good start. So I work on a team called the Cloud HPC Toolkit, and you might think of what we do as building a officially Google supported product that does something very similar to what Michael just described. But kind of very, very general and aimed at all customers interested in large scale analysis. So one criticism of Google over the years has been that we build all these constituent parts, but then don't make it easy for you to use them together. That's really my team's charge, is making all this stuff just easy and work, but also customizable, because we know in the real world you have your own applications that you need to make work with all this stuff. The toolkit is open source. It's on GitHub. We accept contributions from everyone in the scientific community. We also accept contributions from a lot of Google Cloud partners. Usually these are consulting firms that help people get up and running on the cloud. There are discussions, feature requests, all the various GitHub features. The toolkit itself uses open source tools for what it does. The big two are Terraform and Packer, which are products from HashiCorp. These are multi-cloud tools for building cloud infrastructure and images. So Michael talked a lot about AMIs, their equivalents on all the clouds. Terraform does have plugins for on-prem infrastructure, but I can't really speak to their quality one way or the other. And then as a configuration file engine, we have support for Ansible, as well as basic shell scripts, things like that. And the toolkit is aimed at supporting the scheduler and storage solutions from Google. So we have a batch service, we have GKE, but also from partners like the University of Wisconsin. We have Condor, we have Slurm, and there's also some PBS Pro support in there. So the starting point for the toolkit is a file we call a blueprint. I'm going to show you an example over the course of a few slides. The toolkit itself is basically the GHBC command binary, and it ingests the blueprint and turns it into what we call a deployment folder. And that folder contains all the Terraform and Packer stuff to actually become your HPC environment. Taking a step back, like when I worked for LIGO, the first challenge I had was figuring out what the heck to do. Like there's so many solutions that I didn't really know even where to start. So this is really aimed at getting off the ground, but with something that is production ready. There are two commands that you're going to run. I want to make sure people have some of the tool nomenclature in mind as well. So Terraform is a tool that it's a declarative way of building cloud infrastructure. So instead of making API calls, you just say, give me a cloud instance, and it figures out what to do on your behalf. Basically the same thing that Puppet does for files, Terraform does for cloud VMs. Packer is a tool for building machine images. These are basically boot disks for your VMs. And then the GHPC deploy command actually automates how Terraform and Packer get executed in sequence, so that first you build an environment to run in, then use Packer to build a image, and then use Terraform again to build a actual Condor pool. Over the past year, we've added support for Condor in the toolkit. Last year, actually, we happened to be the Condor week happened to be the same day as we were announcing the toolkit itself. So this is more or less our birthday. Things have become easier for Condor now. So image building using Packer is now one command instead of a complicated series of, hey, run this, then cut and paste this. It all just happens with GHBC deploy. We've added support for Rocky Linux 8, and we've also added support for Windows on execute points. We're using ID token authentications throughout, and we've also added support for spot instances. We have a customer that's actually using Condor with Windows and GPU nodes now, so I've been actively working on a lot of this to, make the experience better for them, and that's resulting in a very the blueprint that you would actually use to provision Condor is becoming a lot simpler and easier, and hopefully I can prove that to you in the next few slides. But everything is being managed in instance groups on AWS. These are called auto-scaling groups. But the main point is that instance groups have a health check feature where it can kind of ping port 9618, and if the machine is not listening anymore, it will kill it and recreate it for you. So now all the components of an HTCondor pool are auto-healing. And relatively soon, we're expecting support for more than 2 machine configurations. Right now, we're limited to 2 for reasons I'll discuss. So showing a blueprint YAML file in a presentation is actually a little tough because files are tall and presentations are wide. So you kind of have to imagine these columns, wrapped top to bottom. But each blueprint contains a set of deployment groups. And the way Terraform works, it constructs a DAG, so a directed acyclic graph of infrastructure, and we mimic that approach in the toolkit. So what this blueprint I'm showing you here builds a initial environment that contains just a network and all the installation scripts that you need to set up Condor. You can actually append your own install scripts here that would actually add your own application or dependencies or whatever you need. And then over here, the second group is using Packer to build a custom image. So Michael described, you need a Condor AMI to start your the CloudFormation experience. This is the equivalent in the toolkit for Google Cloud. And the point here is that the Packer module that we've written is set up to kind of automatically ingest all the outputs from these other modules so that you don't have to, the instructions don't become like, okay, run this command, cut and paste this value, so on and so forth. It can dynamically find the network that was created in the first group. Additionally, the network is set up automatically to have outbound internet access and so on and so forth. This is the third group. It would actually provision the pool. We've split things out so that things are kind of plug and play if you want to swap in your own implementation. So base here is just creating service account. Secrets is actually creating the pool signing key and ID token secrets, and then central manager execute point access. And you can see here with the use keyword that the relationships between the infrastructure make sense. So the execute point needs a network, needs an ID token, it needs these are basically like service accounts and buckets and stuff that the solution needs. And then of course it needs a central manager to talk to. Now if you wanted to, you could get rid of this, and instead of using the central manager that you provision in the cloud, you could point it to any old central manager so long as it had the same signing key, and it should just work. But obviously we're mostly focused on the whole pool is in the cloud type solution. So as an example of something we've made automatic, but you can swap out for your own solution, this is just a little bit of what we call runner. It's the configuration as code solution for automating the whole chain. What happens here is it adds a little systemd override to the Condor service on execute points that says, hey, before you start Condor, go get the ID token from the Cloud Secret Manager. And if that doesn't work, then don't even bother to start Condor. And the Condor service unit is set up so that it will actually retry on failure, so that hopefully this eventually heals and Condor starts. But if it doesn't, then the instance group will say, hey, 9618 isn't active. I should just kill this machine entirely. I mentioned our customer needs Windows. The primary challenges have been me not knowing how Windows works. TJ's been a significant help here. I'll mention an error code later that he helped me solve. But one of the things that themes that Michael talked about was like sometimes things are hard on-prem that maybe are easier on cloud, and Windows might be hard on-prem but easier on cloud. So we've automated a solution for Python installation and all the other things. All right, negative feedback. So this is kind of my own experience of trying to do things right. So ID tokens, they're great, they're the future, they're perfect. But at the same time, debugging them is difficult. I listened to the talk yesterday, and it helps, but there's still some very silly problems that you encounter. The one I've encountered twice, so I ran into it 6 months ago, forgot I ran into it, and ran into it literally last week. These two configurations are different. You end up with different trust domains if you use this configuration versus that one. And it's really hard to figure that out until you remember why it's happening. I've also found that running commands as root is just a different experience. It probably just amounts to fetching a token, but it's different, and I think something that's probably a gap in the current Get HTCondor workflow. Okay, and then so we added support for Spot, and we even make it easy through job transforms. And I want to give a shout out to all the documentation here, how easy it was to just follow it and make this work. Getting this to go beyond n=2 may be a little bit difficult because I'm going to have to kind of tag machines with labels and schedule them that way instead of on what I would call real requirements like CPUs, GPUs, and stuff like that. The work Todd is doing to kind of hijack the rooster mechanism for this purpose is important, and I think probably important to the broader community as bursty workloads become more normal. I just want to kind of toot my own horn here. I've reported these problems I've reported problems and gotten them resolved for all customers. And in fact, yesterday, HTCondor admin email address has been blocking me. And they've cleverly made it look like it's Google's fault, but I think they just don't want to hear from me anymore because I'm the bearer of bad news. So with that, thank you.